After an amazing talk by Brian, now is the time when we have next up TechCromancer. So, quite an interesting name, right? TechCromancer. Let's see what chemistry brews between him and technology. Okay, so we've got an additional screen set up over here. If in case people sitting at the back are not able to view things here, they can have a good vision over there as well. So, TechCromancer is a part of Black Lantern Security, and he will be talking about recursion is a harsh mistress. How not to build a recursive internet scanner. In this talk, witness the myriad of strange and unexpected bugs we encountered while building BBOT, a recursive internet scanner. These bugs may appear fun sometimes, hilarious, but not when they occurred extremely problematic. So in this talk, TechRomancer will discuss the nefarious traps and nightmarish edge cases that awaited in the depths of the internet and the destruction they caused. The tricks that you, and also he'll also discuss about some of the tricks that were used to overcome them. We will get to know the kinds of hidden gems recursion can uncover, because recursion has a tendency to turn little bugs into explosive ones. So please give it up for TechRomancer.
Hey guys. All right, welcome. So some of these first slides are just going over what he already said, but first of all, I just want to say, super excited to be at DEFCON, and especially at the Recon Village giving this talk. I feel like you guys are really equipped to hear it, and I have a feeling you'll do some cool stuff with it. So, all right. So this talk is mainly broken into two parts. So the first part is dedicated to bugs. Okay. So these are bugs not that I exploited, but bugs that exploited me. These were basically just like horrible recursion bugs that we ran into while building BBOT. So there's just lots of demos of things failing, kind of fun. So in the second part, I'm talking more about the technical part of it, and then we have a fun announcement at the end as well. So I'm Joel, aka TheTechromancer. Basically, only one thing you need to know about me is that I like to build things. So this was me when I was 6 years old. I loved Legos. I was a huge Lego kid. So when I finally learned Python, in my brain, the Lego logic just kind of became Python logic, and they're kind of the same. So, all right, I'm a pen tester. I've written some security tools. If you've heard of Trevor Spray, ManSpider, BBOT, which is the recursive internet scanner in this talk, is the most recent tool that I've made. Who all here has used BBOT, just out of curiosity? Okay, we have like 4 people. Okay, awesome. All right, so for everyone who hasn't used BBOT, you're in the right talk. So if we rewind back to 2022, I hadn't created this tool yet, and basically Black Lantern Security back then was just sort of like a small startup, up and coming. We had one big client, and this client had a huge attack surface. So our job was basically we needed something that could map that attack surface and basically discover all their external websites and all that stuff. Originally, we didn't intend to make it a recursive tool, or not necessarily. We just needed something that was stable, that we could basically scan a huge target with and it wouldn't break. It was like consistent, and something that was thorough that we could basically, ideally, we wanted one tool that we could run that basically just found everything that we could trust would find pretty much everything. So we tried a lot of different ones, and there are some great tools out there. The ones in this list, like Amass, the Harvester, I ran a lot of these. But what turned me on to recursion originally was Spiderfoot. So something interesting about Spiderfoot is that it's built in a unique way. Its design is totally different from all these other tools. And it's not immediately obvious from looking at Spiderfoot or using it, but like a lot of tools kind of claim to be recursive. You know, for example, like if you've ever used FUF for like directory brute forcing, it has like a recursive option, right? But Spiderfoot is like actually recursive, and And the way that it's recursive is super important because it has like 200 modules, and each of those modules interact with each other. So they're constantly like exchanging like emails and URLs and subdomains between each other, and it's just this huge framework that everything plugs into, and the entire thing is recursive. So it's actually like a really genius design. So okay, so I just sketched out here like sort of a classic workflow for like OSINT or like external attack surface mapping. So you start off with your targets, like your domains and stuff. Throw those into a mass, do some subdomain enumeration, take those subdomains, port scan them, take those open ports, discover web stuff on them, and then finally, at the end you can do like nuclei and stuff, right? Pretty typical, and most of us have probably done this. But yeah, Spiderfoot does not work like this. Like it's not like a phased scanner. So just to explain how Spiderfoot works, because this is also how BBOT works, but I did not invent this idea. Spiderfoot was the first one to do it. Okay, so the way Spiderfoot works is each of its modules do one specific thing. So in this example, I have 3 modules. So we have SSL cert, Nmap, and HTTP. And each of those modules consume a certain type of data and then do something to it and then produce a new type of data. So in this example, the red line is open port and the blue line is host. So you see that Nmap consumes hosts, port scans them, and outputs open ports. And then SSL cert consumes the open ports and basically visits that open port and pulls down the SSL certificates. HTTP visits the website if there is one and extracts like URLs. And then from SSL cert and HTTP, you get more hosts and they feed into Nmap. So like to illustrate this, you start off with like evilcorp.com, right? Port scan it, get open ports. SSL cert finds more hosts, HTTP finds more hosts, gets fed into Nmap, makes more open ports, which make more hosts, which make more open ports, which make more hosts, which make more open ports, and so on, right? So it's not just a phase thing, like it just keeps churning until there's nothing left. And this is recursion, okay? So this is the big idea. This is the big idea that Spiderfoot basically put into practice, and it's what fascinated me about it. So unfortunately, Spiderfoot itself didn't end up working out for us. I tried to make it our like one tool, and it didn't end up working out. I won't get into the details of that, but it did infect me. So once I spent some time debbing on Spiderfoot and got to know it and got to understand how it worked, it really infected me and made me realize that we're kind of like we've been doing Recon the easy, simple way, and there's a much better way to do it, and that's what Spiderfoot was doing. So. At the time, I felt a lot like Spiderfoot's idea was really good, but its execution wasn't as good. So the plan became, build a new scanner that was stable and also recursive. And what could go wrong, right? How hard could it be? It's just Legos. So here's the first BBOT scan that we had. The first scan, the first feature that I added to BBOT was DNS resolution. So what you're watching right here is a recursive DNS resolution of Tesla.com, and it's just DNS records, IP addresses, host names, and basically the result of every DNS lookup gets fed back in, and DNS lookup again on that over and over. So yeah, that's how it's supposed to work. And try and remember like what that looked like, because yeah, that's what a scan is supposed to look like. And because this talk is about bugs, we're about to see a lot of things that don't look like that. Okay, so the DNS bugs were the first to arrive since DNS was the first thing I made. All right, so what is happening here? Kind of weird looking, definitely not looking at all like the last one. So yeah, something is clearly off here. And if you're close enough and you can see the terminal, you might be able to guess what that is. But if we look at what's happening in Neo4j, kind of zoom in and look at it, our target was evilcorp.com. And so you can see that we have evilcorp.com, which has a C name to another DNS name, which has another C name over here, and we have like this chain of DNS C names that goes all the way around and loops back right into the middle. So this is a CNAME loop, and if you know anything about DNS, you know this should never exist. There's absolutely no sane reason to do it. But I promise you it exists, and we ran into it, and it seriously messed with us. So yeah, probably somebody either accidentally did it, or else they were just having a bad day at work and decided to take out their anger on the internet. I don't know what it was, but it was very frustrating. All right, so more DNS bugs. This one is a bit more explosive. But basically, yeah, just wait a second, just wait for it. Okay, so this is more than just a simple DNS lookup. This is, right now what we're doing is a subdomain enumeration on github.io. Okay, so github.io has an interesting quality, which is that it's a wildcard domain. Yes, okay, so how many of you have had fights with wildcard DNS? Yeah, okay, so I'm sure that you probably hate wildcards, and I do too. These cause us a lot of pain in BBOT. And the reason for that is because in a normal tool, like if you ran a mass, for example, and you had a wildcard domain and you got a whole bunch of false positives, right? Because what happens is this. You do a lookup on something that clearly doesn't exist, and github.io is going to tell you, oh yeah, that exists. Here it is for everything. So in a mass, this isn't a big problem because you can just clean them out at the end. You know, you're going to have some extra garbage data, just clean it out at the end. With BBOT, it doesn't work that way because we're brute forcing subdomains of subdomains of subdomains, and so for every new subdomain that we get, it's just going to keep going forever. So yeah, basically in the early days of BBOT, we had a lot of bugs, and they just kept coming. Like first we had the DNS ones, and then once we implemented web, we had the web ones, and web just opened up a whole new dimension of like possibilities for things to go horribly wrong. And sometimes these would collide, so sometimes we'd get interactions between like DNS bugs and web bugs, and those were always the worst. So there's this one time. It was early on. I would basically take like the sort of like alpha version of BBOT that we had going, and I'd take it and I'd give it to our operators. You know, they were on an engagement. They were doing OSINT. I was like, hey guys, you like run this, test it out for me? Like, sure, why not? So I got dragged into a Teams call, and they were basically telling me that like they ran BBOT and one of the customers' websites went down. And well, first I asked like, which modules did you enable? And they said all of them, obviously. So basically, there are other modules besides just the web module that we have that visits websites. For example, we have a nuclei module, which does like vulnerability scanning. So what happened, and this took some investigation, but what we found out is that there was a DNS wildcard, there was a bug in BBOT that failed to detect the wildcard, and then basically we had 1,000 URLs, and each of those URLs was getting nuclei ran against it, but because they were a wildcard, they all just brought it back to the same server. So basically all of nuclei's like parallelized scan was just getting routed into one server, and that poor server could not handle it, sadly. So yeah, example of kind of like how DNS and HTTP like combine together to screw us over. BBOT had this problem where one moment it would be going along normally, it would just be a normal scan, everything would look fine. I'd get up to like go get a snack, and when I came back, it would just be scanning something completely out of scope or just doing something crazy, and I'd be like frantically canceling it. So, and this wasn't just with wildcards. Like, we had issues also with like cloud. So, has anyone ever like ran like a scan and had like a big list of targets and realized halfway through the scan that there was a target in there that you didn't want to be in there? Like maybe like a cloud domain or something like that, like Azure.com. This was kind of an issue with BBOT, right? Maybe you had like a cloud bucket or something in there accidentally, right? Bad things can happen. So right here what we have is we have what starts off as just a normal subdomain enumeration of spacex.com. So you can see, just lots of sort of URLs, DNS names, IP addresses coming in that belong to SpaceX. But if we watch this for a little while, I'm going to fast forward it a little bit. what you can start to see happening is we start to see some weird little things spin off to the side here. So what happened is SpaceX at this point, they had well, first of all, SpaceX they do government contracts, so they use Azure for a lot of their stuff, but it's like the government version of Azure. It's like azure.us. So what happened was there was a bug in BBOT where it would see a SpaceX domain that had a CNAME into Azure, and there was a bug where it would be like, oh, azure.com, yeah, that's in scope, and it would just start to enumerate all of Azure, which obviously is huge and obviously not what you want. So over here, this one over here is azure.us. This one's azure.com. Like this cluster at the bottom is like microsoft.com. And it's just like going ham. So this is a scan you do not want to leave running for very long. So yeah, there's this one time when we accidentally scanned a .gov. This was kind of embarrassing. What made it worse was that we found a critical RCE on the .gov. And so we were like talking like, should we report this? Obviously we have to report it. It's a .gov. It's a critical. So I can't say a lot about this, sadly, but the gist of it is that yes, we did end up reporting it, and no, it did not end up getting fixed, and yes, it did end up getting exploited, and it may or may not have been in the news. So that was an experience. Yeah, we had some accidental accidents happen. And this was kind of normal for Spiderfoot. Has anyone used Spiderfoot? Okay, yeah. So if you've used Spiderfoot, you may have had a good experience with it, but you may have noticed, like, especially with bigger targets, it can start to run into issues like get stuck spidering a website, or you might end up with some garbage results that you don't want. So this was, something I'd already experienced with Spiderfoot, but kind of something I thought I could fix and thought wouldn't happen to me, but it totally did. And so, yeah, basically, Spiderfoot had a scope system, and I just didn't think it was fixable. I thought I could write my own that was better, it didn't work out quite like I planned. In the back of my head, I had always kind of wondered why Spiderfoot was the only one, why Spiderfoot was the only recursive tool. OSINT, when you think about OSINT, right, OSINT is just like, Recon, OSINT is just like relationships, and so it's a recursive problem. We know it's a recursive problem, we've known this for a long time, so why aren't all our tools recursive? Why are they all just sort of like linear scanners? And there's a really important reason for that. And this was what I was just beginning to discover, which was that recursion is the mortal enemy of stability. So when I say I wanted to make a scanner that was both recursive and stable, that was a lot harder than I thought it would be. So speaking of stability, I want to show some more bugs. This is kind of a weird one. And this starts off in the same way as the cloud one, with a subdomain enumeration of SpaceX. I'm going to fast forward a little bit for time. We start to see something similar, though, where on the bottom of the scan, if you watch close to the bottom, something weird starts to happen. Uh-oh. Okay. All right, so again, if you're close enough to see what's happening in the terminal, you can see that what we're getting are just a whole bunch of URLs. So what exactly is happening? This is all the same host, and it's just like tons of URLs coming in. So basically, what this is, if we look at it more carefully, is it's an infinite redirect. So what happens is on some pages, and this should never happen, but it definitely does sometimes. You might get redirected to another page, but what happened in this case was we had a redirect that when you followed the redirect, it would basically generate a new random URL and redirect you to that, which when you visited that would redirect you to another random URL. So basically, it would just go on forever. And yeah, if you visited that in Chrome, it would tell you this, like the error, too many redirects. You might have got this in the past. But if you scan that with the recursive tool, and you don't handle that edge case, it's going to produce giant tendrils of doom, and it's never going to stop. So yeah, the web bugs were real. There were many times, there were actually 3 separate times that we accidentally made a web spider. This may seem silly. But it was like it was a real problem, and the reason is because when you have a recursive tool, like a recursive system, like BBOT, there's actually only two ingredients that you need to make like a full-blown web spider. So the first one is you need to visit URLs. Simple, right? And the second ingredient is you need to extract the URLs from that response. That's a loop. It's all you need. If you have those two things in a recursive tool, you have a web spider. So if you're curious what a rogue web spider looks like, this is what it looks like. This is BBOT web spidering the Linux kernel documentation. Which, by the way, if you ever have a web spider, the kernel documentation is a really fun sort of like test bed for that. Well, first of all, because the Linux people have super fast servers and they're really good at keeping everything running. But also because there's just lots of goodies in there. Like, for example, if you run BBOT on the kernel documentation and you enable the web spider, it will not only pull out URLs and visit them, but it'll also pull out email addresses. It'll download files like PDFs, Word documents, that kind of thing. And basically, yeah, just if you look carefully, somewhere in here, there's like Linus Torvalds' email. It just like scrolls by. But yeah, kind of fun. So yeah, basically, the bugs kept coming, and like at this point, I kind of had to take a step back and like consider whether recursion was actually worth it. Like in the beginning, I was very sure that I wanted to make a recursive tool, but as I started to see all these bugs and realize how hard they were to squash, I started to realize how much work it was going to be to really like make this and to keep it stable. So yeah, I felt like there was always new bugs cropping up, and whenever I fixed one, just another one would come back in its place. And I felt that if I like kept going, there was a good chance that BBOT would just collapse and like basically collapse under its own weight, and it'd be too late to go back, and like the whole thing would just be a character building exercise, which I definitely didn't want. So yeah, reminded this like Calvin and Hobbes, just builds character. So basically, I had a choice. I could either remove the recursive part of BBOT and just make like a simple scanner, or I could kind of try to tough it out and kind of see what happened. So yeah, obviously I chose recursion. I wouldn't be here talking about it if I hadn't. But Spiderfoot had done a number on me. Like I could not, after using Spiderfoot and being so sort of like enamored with it, I definitely could not go back to anything that was not recursive. So like, what were the consequences of that? Well, they were pretty excruciating, especially at first. So the most excruciating thing that we had to deal with was unit tests. Okay, if you haven't experienced the pain that are unit tests and like CI/CD pipelines, I definitely envy you. This is what you're supposed to do in software development when you write a big software project. You're supposed to write tests that basically just make sure that everything is working and don't let you commit code unless it's working. But I have to say, like, even though it was very unpleasant to have to learn how to write tests, because this was the first thing I'd ever have to use tests for. Like, I'd written hacking tools before, never written tests for them, just kind of got away with not doing that. But BBOT could not exist without tests. Like, we have a unit test for everything. Every one of those bugs that I showed off, we wrote a test to make sure that it doesn't come back. And we have over 100 modules, and every single module has its own custom test that runs it and makes sure it's working exactly as intended. And all of this runs every time you push new code to BBOT. So basically, this is like the structure that's holding it all together and holding it up and making sure that it stays stable. So yeah, by embracing recursion, I was like sort of torturing myself, and I realized that. But it was really humbling, and it taught me some important lessons about recursion and about the internet, and kind of just about life too, because it kind of changes the way you think about things. I think the biggest lesson I learned, the biggest lesson was that maybe I'd been a little bit too hard on Spiderfoot. I kind of felt bad for that. But in almost every case, whenever there was a crazy bug like that, almost always it was just because I was thinking about it in the old way, and from that perspective, it just seemed super complicated. But as soon as I could get in a recursive mindset and kind of imagine how it worked in that recursive system, most of the time the real solution became clear, and most of the time it was pretty simple. Okay, one of the biggest lessons, or I guess solutions that I was forced to come up with to deal with these recursive behaviors was scope distance. This is just basically an internal feature of BBOT that just helps keep those explosive edge cases from happening and lets you kind of step safely out of bounds 1 or 2 hops without worrying about going completely crazy. And it's just basically it turns scope into a threshold. Instead of just being in scope or out of scope, you can kind of see where every hop that you go out, you increment the scope distance by 1. And if you hit something that's in your target, it just resets to 0. And this is what we use in BBOT to basically allow it to do all of that spidering and stuff in a safe way. All right, so in the end, it was the combination of 2 things mainly that made BBOT possible, that made even building BBOT possible, which was recursive thinking, recursive approaches to problems, and then just lots of unit tests, lots of unit tests. And was it worth? What was it worth the suffering? So this is the big question, right? So I want to show you something, and this is not directly related to BBOT, but it's kind of cool. So has anyone ever used Trickist? Has anyone heard of Trickist? Okay, we got one guy. So Trickist is kind of a new platform that basically allows you to construct what are essentially workflows with your hacking tools. So what we're looking at right here is a Trickist workflow for subdomain enumeration. So you can see that there's a whole bunch of different phases. The first phase, we have all of our targets going into these 6 tools. And if we zoom in, you might recognize some of these. We have find domain. And so basically Trickist has taken all of these tools and basically created almost like a glorified bash script out of them, where it's connecting the input of one tool to the output of another tool. And so we have these 6 subdomain enumeration tools doing passive enumeration. And then we have a DNS brute force over here. So you just follow the flow of this. It's kind of interesting. The first time I saw this, I was really amazed. Trickist is really cool. If you haven't checked it out, you should check it out. It's pretty neat. So then we have, after the brute force, we have all of those subdomains being fed into a permutation phase, where it basically makes mutations of those subdomains and tries to find those. So finally, if we go down, we have this phase 2 where we do port scanning and we do websites. So this is basically sort of the standard subdomain enumeration workflow with Trickist. But there's something interesting about this, which is that you'll notice it's not recursive. So I ran this workflow on Dell.com, and it found 11,000 subdomains. Oh, Dell.com is a pretty big domain. I just kind of picked it because it was big. But here's a question: who would win? All right. So we have the 6 tools duct taped together, or just one tool, right? So how much does recursion actually get you, right? This is the big question. You all want subdomains, right? Just give me as many subdomains as possible. So here's the BBOT command that I ran. We have a subdomain enumeration. BBOT found 18,000 subdomains, which is 53% more than all 6 of those tools combined. So essentially it found over 6,000 subdomains that the other tools did not find. So to sort of understand what are these subdomains it's finding and how it's finding them, you have to basically look at the data in BBOT. BBOT tracks exactly how it discovers each of its things. So each event that BBOT emits, so its DNS name, has a discovery path. This particular discovery path for this subdomain, which is one of the subdomains that was missed by the Trickist workflow, has 13 steps. So if you can't read it, I'll just basically summarize really quickly. So we seeded the scan with Dell.com. Basically, there was an API search that happened that found a subdomain. That subdomain had an open port, which basically when we went to visit it, had a redirect that went to this login page. So after visiting that login page, BBOT stepped down one directory and visited that and extracted a URL from that had a different subdomain, and basically extracted the DNS name from that subdomain. And then that DNS name had a C name that pointed to this one. So basically just like this huge chain of discovery that you never could have gotten without recursion, right? We're like 13 levels deep in recursion here. And this subdomain is at the very end. So how are you going to get that, right? Here's another one, right? Seeded the scan with Dell.com, searched an API. That host name had a quad A record that had a pointer that had another quad A record that had an open port that had an SSL certificate that had a quad A record that had a nearby IP address that had a pointer record that had a quad A record that had an open port that had an SSL certificate. Okay, like how are you going to get this? Like you know, we could do this. We're humans. Like we could follow this path, right? But how long would it take you? You know, for 18,000 subdomains. So yeah. Same, PayPal.com, another one. PayPal.com, Trickus found 1,500. BBOT found almost 4,000, more than twice as many subdomains. And this is thanks to recursion. This is thanks to us brute forcing subdomains of subdomains, just following those crazy chains of like, you know, visiting the website and extracting SSL certificates over and over and over again. What about the speed though? Like how fast is it? So BBOT is a little bit slower, and this makes sense because, you know, how is it going to get those giant chains? Trickus workflow took about 5 hours, and BBOT in this case for Dell.com took about 6 hours. So a little bit longer. I think it's tempting. It's definitely tempting to just like take BBOT and just like plug it into like there's 6 tools in there right now. Like just add BBOT, like make it 7 tools. Please don't. Please don't do that. You can if you want, okay? But consider this, okay? So let's go and let's edit this workflow. Imagine that you want to discover those far out subdomains, those ones that like you can't reach just by doing this, right? So in order to do that, you'd have to basically take the output of this web phase down here, and you'd have to feed it back into the brute forcer. So basically what we'd have to do is we'd have to like copy the brute force and like stick it after the web, right? And by then we're like, how many levels? We're like, you know, 3 levels. So then after that, you know, oh crap, now we have to do web again. So we have new subdomains, we have to do the web thing now. And then, oh no, now we have to like do more brute forcing now. You see the pattern, right? Like how many times you're going to do that before you realize it needs to be a circle. Like it just needs to be one nice little circle that goes around and around and around until there's nothing left. So that's what recursion is. That's how BBOT works, and that's how it's able to find these crazy subdomains and things that are just way out there. Okay, so yeah, so basically starting to wrap up here. Basically, this is kind of a silly meme, right? But like it really gets to the essence of what I'm trying to say, which is that like if you're willing to be patient and you care about finding as much as possible, recursion is your friend. Okay, and like in that case, it's best if you can take that recursive algorithm and make it at the highest level of your automation. In other words, like make it the framework that you plug everything else into. You know, maybe that's BBOT, maybe that's Spiderfoot, but I can't emphasize enough like how important it is to have a recursive system. Yeah, again, like OSINT is a recursive problem, and when you approach a recursive problem without a recursive algorithm, your solution will just get more and more complex infinitely without ever reaching an end, just like you saw with like the Trickus, you know, that like us keep adding phases to that. So yeah, like I like this quote from hackers. When I was a child, I spoke as a child, I understood as a child, I thought as a child, but when I became a man, I put away childish things. Okay, so I feel like as a community, I think we can handle recursion. I think we could do it. So on that note, I want to announce that BBOT 2.0 is releasing today. So it is out right now, and you can install it with pip. So yeah, there's a lot of new features with this. I wish I could get into all of them. I wish we had time to do all of them. But yeah, basically, like the gist of it is that we have 10 new modules. It's a lot faster. It's faster by almost an order of magnitude, like almost 10 times. We have things that make it a lot easier to use, that allow you to put all your settings in just like a single YAML file. We have Yara integration, so you can basically think of like Yara integration as just grep tech R for like your target's entire web presence, which is pretty cool. But yeah, check it out. We have a GitHub. We have lots more in the pipeline. So like development is happening at a super fast pace. Like we're adding features every day. There are some awesome people in the community who are writing new modules and adding new features. Some of the features that are up and coming are going to be super cool. I'm actually super excited. We have features that will automatically download Git repos, Docker images, and like extract them and loot them for like secrets, extract URLs from them and feed them back into this giant recursive machine. So yeah, it's gonna be awesome. Oh, and it's a Python library. So if you're into Python and you are wanting to automate something with BBOT, this is the way to do it. It's basically super simple. Pip install BBOT, from BBOT import scanner, and you can do everything in the Python library that you can do on the command line, and even a little bit more. So yeah, all right, so thanks everyone for coming to this talk. I hope it inspires all of us to think recursively, and yeah, thanks. If there's any questions, I'll take them now as well. Any questions about BBOT or recursion or anything like that?
I got a question for you.
Sure, go ahead.
Like, why are rogue spiders bad? Like,
Okay.
what is the problem?
Good question. Okay, so the question is like, why is a rogue spider bad? Like, why wouldn't you want that, right? And in some cases, you absolutely do want that. But say, for example, that you're just doing like a simple subdomain enumeration, you need it to finish in like a day. If we were to enable that spider for like Dell.com, imagine how many pages Dell.com has for like documentation and stuff. Like it'd be like a week. It'd be a week. So in BBOT, we allow you to control exactly the distance that you want to go, how deep you want to go with the web spider, and how many hops. So you can be like only 10 hops, no further than that. So you can definitely dial it in to exactly what you want, or you can just turn it up to 99999 if you want to. Yeah, whatever you want. All right. Go ahead. Oh, yeah. So the question is like, how many times do you think those recursion bugs were just like intentional tar pits to mess us up? I'd say a lot of the time. Yeah, definitely. There are some like just sort of like chaotic and very chaotic evil people out there who just like want to watch the world burn. Or maybe they just don't want you spidering their website. Like some sysadmin's like, good luck spidering this, man. So yeah, but also, plenty of times people just accidentally misconfigure DNS, or like make a recursive like link accidentally. So that also happens. Yeah. All right. Cool. Anyone else? All right. Thank you.